Welcome to GDP's Graphics 2 2020. My name is Felipe Bellini and this is a video demonstration for Project 1 addressing the classes lectured by Michael Finney at Fanshawe College. Project 1 is about off-screen rendering and combining passes in the shader. In this project, we should be able to see a couple of scenes being rendered. Some will be displayed with visual effects or a combination of them. Let's go over the results of this work. So here's the OpenGL application. As you can see, there's a bunch of portals laying around. I'm gonna go over each of them. First thing to notice here is a sphere in the middle of the room. This sphere is using a reflection, which was a topic that was covered in the first term. So here's the sphere reflecting the cube map, the skybox. So before going into the portals, I'm going to back away from the scene to show you that these are indeed portals and not cutouts. So you can see what's happening here. As you can see, our room is covered by these bricks. There's no hidden scenes outside. They're still showing inside. And again, I'm moving away, show you the other side. This. Then okay, great. So the first portal I'd like to show is this one in the middle. This is the original scene, the second scene, and then we're going to apply a bunch of effects to this scene while it's being displayed. That's all happening in the shader with a combination of passes. So yeah, so I have a camera in this scene, and the scene is being displayed using its own camera as the perspective. We can change that. We can have different cameras to have different views, points of view. This is a static shader. We can't see anything in the actual scene because it's being overridden by the static shader. But then if we look into this portal here, we can see that both things are blending, right? So I have this TV static, and also I have the actual scene being rendered, one on top of the other and blending by 50%. I could have like 3 or 4 passes being applied, and they would have like an equal amount of weight. Here we have a night vision kind of thing going on. So we see the original scene and the ball that's bouncing. It's being viewed in a night goggles kind of thing. Here I have a sine wave effect that gives us kind of a weird idea where the image is being distorted, but it's also moving, kind of like kind of like the dream world in Max Payne, I guess, the first game. Here's another one that shows the combination of the night vision plus the actual scene, and on top of that we also have a different camera, so it's showing the camera from one of the points in the quad, so it's different from the other cameras, as you can see. That one that looks black and white was an example of the depth buffer. I changed it just a little bit so it would show better here, so you can see, because it's too dark. This one shows blur effects, and also it's kind of following the GL pixel kind of thing, which shows the camera. GL coordinate, I guess it's the name of the variable in the shader. So that's, as you can see, it's blurred, but it's kind of have this weird effects where it follows the camera wherever I look at it. This one is also blur, but the camera is static, so if I get really close to it, you can see that there's a blur in the edges here. This one is one of the most interesting ones. So I'm basically rendering this vision, the actual main scene, on the quad also. So we have the actual everything that you see as I move the mouse is being rendered to that quad, that portal. So if I get really close to it, there's a kind of an effect where one thing is being rendered on the other thing, on the other thing, on the other thing, the infinite mirror sort of thing. Yeah. So this was a very interesting project that shows how we can deliver effects like scopes, lenses, security cameras in games, monitors, and all sorts of things really that are running in a different scene somewhere else in the game. So here's the shader. You can see here I've made some structs here to accommodate data that I'm passing through the C++ side. So for instance, this is time information that I use to calculate the sine waves for the distortions and also for the static on the TV. And there's a bunch of information here, like the allocation, could be plane information. We have a structure here for textures, another one just a little bit below that regards the passes. So this is interesting to this project because it passes how many passes each pixel has, and also which passes are available for this pixel in particular. So in our main function, I test if there's an amount of passes to be done. If not, then there's no pass. Then I just apply the regular shader effects, like I apply a texture to an object or create a skybox or whatever it's needed. But if it does have a pass, then I will loop through that pass array count, and then I will combine all the effects from the pass array. So for instance, if I have blur effects and TV static, then the result of this pass will be added to the result buffer, and then the result buffer will be divided by the pass array count at the end, so we can have a blend of 50% per each, like this. This is the most important part for full screen texture, or full screen pass blending, or multi-pass, or whatever. So here's our passes functions. There's a bunch of comments in here, so you can look like the sinus wave, for instance. Here, there's a couple of comments here, very simple. That summarizes the presentation for this project. For more information, contact Michael Feeney or Felipe Bellini at Fanshawe College. Thank you.